So, finding zeros of polynomials. Here's where we start. Let's make it big enough so that you can see it. 200%. Okay, so if we have an equation already in factored form, and you can of course tell it's factored because it has parentheses around it, you find the degree of the polynomial by adding all of the exponents of every factor. Okay, so this has an exponent of 2. Sorry, I covered that up there. Let me see. No, that's not what I want. There it is. We have an exponent of 2 plus an exponent of 1. So this has a third degree polynomial. Okay, if it's not already factored, of course, if it's in standard form, you just take the highest exponent of the highest power. So this has a power of 2. 2 plus 1 is 3. Okay, the zeros of your polynomial come from your factors. So what number minus 3 equals 0? That would be positive 3. And what number plus 5 equals 0? That would be negative 5. So your zeros or your roots are always opposite of your factors. And then your multiplicity is talking about how many multiples of each 0 there are, and that of course comes from your powers. So x minus 3 is raised to the second power, so it has a multiplicity of 2. And x plus 5 is raised to the first power, it has a multiplicity of 1. So your multiplicities should always add up to be the same as your degree. So 2 plus 1, thank goodness, equals 3. So we have all of our zeros possible. Okay? So the multiplicities also tells you what the graph does at the 0. So if you have an even multiplicity, that means the graph will bounce at that point. If you have an odd multiplicity, the graph will cross at that point. Okay, so if we were going to sketch this, and we're going to do that down on number 3, but if we were going to sketch it, we have negative 5 crosses at negative 5 and positive 3 it crosses. Because this is a positive cubic, it will start going up like this. It will come back down to positive 3 and it will bounce. So this is what the multiplicity does. It tells you whether the graph crosses at the 0 or whether the graph bounces at the 0. Even multiplicities bounce, odd multiplicities cross. Okay, always, always, always. Okay, let's move over to number 2. Why don't you take a second to try this one. So on this one, notice we have 3 factors. We have x as a factor, we have x minus 1 as a factor, and we have x plus 4. So here is a 1 power plus 3 power plus 2 means we have a 6th degree polynomial. Okay, even though this one is not in parentheses, it still has a power of 1. This one has a 3 and that one has a 2. So the zeros, our x contributes a 0 of 0. Your minus 1 contributes a 0 of positive 1. And your plus 4 contributes a 0 of negative 4. And once again, the multiplicity, x is raised to the first power, x minus 1 is raised to the third power, x plus 4 is raised to the second power. 2 plus 3 plus 1 equals 6. We got all of them. Okay, so if you were going to graph it, it would cross at 0. It would cross at 1, because this is an odd multiplicity, and it would bounce at negative 4. So any odd multiplicity crosses, any even multiplicity bounces for your graph. Okay, good thing to remember when we're trying to sketch. let's just draw this in real fast. Here I have negative 4, positive 1. So here's a 0, here's a 0, here's a 0. Okay, it would bounce at negative 4, cross at 0, and cross at 1. Okay, we know it's this way because this is a negative polynomial. There's a negative out here. Negative even polynomials have brownie face end behaviors. So both the arrows point down. Okay, so we can do more of that here on number 3. Okay, so we're going to sketch, not perfect, just sketch, finding the zeros and the y-intercept. Okay, so the zeros are, of course, negative 2 and positive 1. Okay, the graph will cross at negative 2 because it has an odd multiplicity, and the graph will bounce at positive 1 because it has an even multiplicity. Okay, to find the y-intercept, we multiply all of the numbers together. So here is a positive 2 times negative 1 squared. So here's our negative 1 raised to the second power. 2 times negative 1 squared is positive 2. Negative 1 squared is 1. 1 times 2 is 2. So we have negative 2 as a 0 and positive 1 as a 0, and it has to cross at 2. Okay, this is a positive cubic, positive odd polynomial that crosses at 2. Okay, which means we're going to start down here in the third quadrant, and we're going to end up here in the first quadrant. Okay, all positive odd polynomials have that property. Starts in the third quadrant, ends in the first quadrant. And it has to cross at negative 2. Okay, and bounce at positive 1. Okay, so there's a local maximum in here somewhere. I'm not exactly sure how high it's going to go, but I know it's in there. And it will come back down to the local minimum at positive 1. Okay, so with your x-intercepts, your zeros, and your y-intercepts, you can basically sketch the graph of any polynomial. Okay, so this next question, we're asked to find the quotients of this. So here we have a polynomial divided by a binomial. Because we're dividing by this, we can use synthetic division. Okay, if this divisor was anything other than linear, we would have to use long division, synthetic division. Because this guy right here, x minus 2, is linear. Okay? If we have a linear divisor, you're able to use synthetic division to find the quotient and the remainder. So with synthetic division, the first thing we have to do is solve that divisor. Okay, so 2 is the value that we're going to use to perform synthetic division with. Now with synthetic division, we only take the coefficients. So x to the 4th has a coefficient, x cubed has a coefficient, x squared has a coefficient, x does, and of course just the number. So, coefficient of x to the 4th is 1, x cubed is 5, x squared is 4, minus 10, and minus 12. Okay, so these are all the coefficients. Make sure you have every single power accounted for. If you're missing one of the exponents, make sure you have a 0 in there instead of leaving it blank. Okay, so the process of synthetic division, you always just drop down that first term, and we multiply. 2 times 1 is 2, and add. 5 plus 2 is 7. 2 times 7 is 14, and we add 18. 2 times 18 is 36, and we add 26. 2 times 26 is 52, and we add 40. So the number on the outside multiplied by the number on the bottom, and then you put it here and we add. So now we have to come back here and decipher what we have. So remember, this last term is your remainder term. What's left over? This is your number. This is the x coefficient. That's the x squared coefficient. And that's x cubed. So this stuff is your quotient. Once you write it as a polynomial, this is your remainder term. So your quotient is x cubed plus 7x squared plus 18x plus 26. Okay, that's the quotient or the polynomial that you get when you divide. Sometimes referred to as q of x.
It's crazy, man.
Okay, and the crux of it is this last stuff, finding the zeros of your polynomial. Okay, with nothing given. The first thing we have to do is talk about your potential zeros. So your potential zeros always come from the factors of your last number divided by the factors of your first number. In this case, it's a 1, so we're just going to have the factors of 6. Plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. Okay, if this number were anything other than 1, we would have plus and minus the fractions of 1 divided by that number, 2 divided by that number, and so on and so forth. Everything that's unique, no repetitions. Okay, so once you get your potential zeros, we do synthetic division to find an actual zero by looking for a remainder of 0. It's a lot of words, 0. So let's account for all of our things. Here we have our x cubed coefficients, x squared, x, and your number. Okay, so x cubed has a coefficient of 1. There is no x squared term, so that's a 0, minus a 7, and a minus 6. Remember to account for the missing variables. There's no x squared in this problem, so you have to put in a 0. Okay, so now we try each one of these until we find one. So let's try and find one. Does one work? Nope, 1 does not work. So, get rid of all this stuff. 1 doesn't work. We'll have to try something else. Try -1. Okay, -1 here, -1, +1 here, -6, +6, 0. So that's what we want. We want to have a remainder of 0, which means -1 will be one of our real roots. Okay, so -1 is definitely one of your answers. Okay, the other answers come from the quotients. Come from this thing. This gives us an x squared minus x minus 6 quotient. Okay, we want to know what numbers will make that equal to 0. So hopefully this is a factorable quadratic. Are there numbers that multiply to give you -6 and add to give -1?
Yes.
Those numbers are -3 and +2. Okay, so these lead to an x minus 3 factor and an x plus 2 factor. And from what we talked about before, the factors and the zeros are always opposite. So this gives you a positive 3, 0. This gives you a negative 2, 0. So we started off with a cubic. We expect to get 3 answers. We have our 3 answers, and we're done. So start with the potentials. Use synthetic division to find one. Get the other 2 from the remaining quadratic equation until you get all 3 of them for cubics. Okay, notice on this next one we have a 4th degree polynomial, so we're going to have to use synthetic division twice, because a 4th degree polynomial will give us a cubic after we find one, and that cubic has to be whittled down to a quadratic before we can find them. So let's see, factors of 12, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 12. Okay, synthetic division, 1, 5, 4, minus 10, minus 12. Okay, try some. Okay, so we find one at negative 2. Minus 2, this is a positive 3. This is minus 6. Minus 2, this is a positive 4. Positive 12, 0. Okay, so negative 2 is going to be one of our roots. So now we have to use synthetic division one more time, and we use our quotient. So we're going to use these 4 numbers, and use synthetic division once again. Okay, because this is a 4th degree, so we're left with x cubed plus 3x squared minus 2x minus 6. So here we have a cubic just like we had in the last problem. So we've got to get our cubic down to a quadratic, because we have lots of ways to solve quadratics. So once again, let's use synthetic division to figure out one of the zeros of this thing. So it turns out that negative 3 works. Okay, so negative 3 is also going to be one of your zeros. So you had a 4th degree polynomial. You found a cubic, or a 3rd degree. You do it again so that we get a quadratic, so that we can easily solve this thing. So we're left with x squared minus 2. Okay, we don't have to worry about factoring it because it's only 2 terms. We can just solve this straight away. X squared equals 2, square rooting both sides, and we get your last 2 zeros. Okay, so all 4 of your zeros are negative 2 from synthetic division, negative 3 from synthetic division, the square root of 2 from solving, and the negative square root of 2 from solving. Yes. So we do this because it was a 4th degree polynomial to start with. So use synthetic division to make our 4th degree into a 3rd degree. And then we use synthetic division to make our 3rd degree into a quadratic, or 2nd degree, so we can solve quadratics in lots and lots of ways. So here you have your polynomial graph matching. So you're given a polynomial over here, and you want to match it up with one of these 6 on this side. Okay, so you have to remember the 3 things that you need to remember, of course. They are, is the graph positive or negative? Okay, is it an odd polynomial graph or is it an even polynomial graph? And what about the y-intercept? Okay, so I'm going to go through and do it for all 6 of these, and then we simply have to match them up with the ones that work over here. Okay, so this graph is a positive graph. It's an even polynomial because it is smiley faced, and it crosses at 0. This one is a negative. It's also an even polynomial because it's frowny faced, and it crosses at 3, positive 3. Okay, this one is negative. I know it's negative because it starts in the 2nd quadrant and ends in the 4th quadrant. So this is a negative odd polynomial, and it crosses at -6 is the y-intercept. This is a positive odd, and it crosses at 6, 12, 18, like 15 or so, I would say. Okay, this is a negative odd because it has a 2nd quadrant, 4th quadrant, and it crosses at, looks like, -8 or -9-ish. And this one, once again, is negative even because it's a frowny face, and it crosses at, looks like 9. So we just have to match up each of these 6 with one of these 6 equations. So for number 7, I have a negative odd polynomial, negative odd, that crosses at -8. So, oh, down here. So my -9 must have been incorrect. We'll call this one E. This is a negative even that crosses at 3. Well, that matches up with B. This is a positive odd that crosses at 15. 1 times -3 times -5 is 15. X times x times x is x cubed, which is why I know it's odd. Positive odd crosses at 15. There we go, D. This is a positive even that crosses at 0. Notice there's no number here. That must be A. This is a negative odd that crosses at -6. Negative odd crosses at -6. Oh, it looks right here. See?
How do you know if it's even or odd?
By the power. So this is a 5th degree. The 5th degree is 5 is an odd number, so I know it's an odd polynomial. 4 is an even number, I know it's an even polynomial. This last one is a negative even that crosses at 8. Oh, maybe this one was 8. Should have been F. So we're looking for 3 clues. Is it positive or negative, first of all? Is it an odd or an even polynomial? Okay, looking at the highest power of x. And then looking at the y-intercept, where does it cross that, and then match them all up. Okay, so those are your 3 clues when it comes to graphing a polynomial, or rather matching a graph with an equation. Okay, and then the last thing down here, you want to make your own polynomial given the zeros. So we should remember that your zeros and your factors are always opposite. So from your zeros, you need to make some factors and then multiply all of it out. So a positive 1, 0 has an x minus 1 factor. A negative 1, 0 has an x plus 1 factor. And a positive 3 has an x minus 3 factor. So your factors are always the opposite signs, or the opposite positivity of your roots. Okay, and now it's just a big multiplication problem. So let's start off by multiplying these 2 binomials together. X times x, x times 1, negative 1 times x, negative 1 times 1. Okay, and then simplify further, leaves me an x squared minus 1. And I still have to multiply by my x minus 3. Okay, so just attack them two at a time. We know how to multiply two binomials together. We've been doing that since pre-algebra, I hope, and you're confident with that. So now your last step is to multiply these ones as well. So x squared times x squared times minus 3, negative 1 times x, negative 1 times negative 3. Okay, the last thing to do is check, is it in standard form? X cubed followed by x squared followed by x followed by your number. This one is, so it is done. This would be the polynomial that gives you these three zeros as the answers. Okay, so it starts by remembering that your zeros give opposite factors. Okay, so same thing over here, only you notice we have some imaginary numbers. Okay, these two go together, we call them a conjugate pair. Okay, so what you want to do here to get the factor is basically unsolving these. We know that x equals plus and minus 3i as the solution. So if we were going to unsolve it, the first thing we would do is square both sides. Gesundheit. There was a sneeze, by the way. Okay, square both sides. So what we get over here, 3i times 3i, 3 times 3 is 9, I times I is I squared. Okay, if we remember, I squared is always replaced with negative 1. 9 times negative 1 is negative 9. So now we have x squared equals negative 9. Okay, if we're unsolving this to go from a solution to a factor, you have to do it this way. So now we're going to add 9 to both sides because we want this to equal 0. So we get x squared plus 9 equals 0. Okay, we have successfully unsolved it. That means that these two zeros give you this one factor. X squared plus 9 is the factor that gives you these two answers. And of course we have our positive 2, which gives us an x minus 2 as its factors. Okay, so anytime you have an imaginary zeros, you're always going to get an x squared plus factor. If these were radicals or real zeros, you would get an x squared minus factor. It always happens to be like that. So our final thing is to multiply this out. X times x squared is x cubed. X times 9 is plus 9x. Minus 2x squareds. Minus 18. Okay, the last thing to do is write it in descending order or standard form. X cubed minus 2x squared plus 9x minus 18. So once it's in standard descending order, you're done with your polynomial. This is the cubic that would give you these three answers. Okay, doke. Doke oak.